Welcome to the first day of summer general physics. In this second video, we're going to have a brief introduction to what physics is all about, and then start looking at some of the tools we'll be using in physics, such as scientific notation and some math tools as well. So this first slide contains a question, and this is one of the clicker questions. So if you're arriving late to the class and you're going to miss the first day, these first day questions are not going to count towards your final grade, so they will be excused. But primarily, the purpose of this question is to give everyone practice using their clickers. So the question asks, my favorite fundamental force is, and the fundamental forces are listed below that. So of course, this is not a question that has a right or wrong answer, but after discussing the question with your peers, if you were in the class, you would then select and vote on this question with your clicker. So for example, after thinking about it some, you might decide that your favorite fundamental force is gravity. So you would select gravity. I know it's my favorite fundamental force. And then we would see a tally of how many people in the class voted for each one of these options. So next we want to have a brief discussion of what is physics anyway. So physics is sometimes called the most fundamental of the sciences, and this is because it is concerned with looking at fundamentally what's going on in the universe. We want to build models to describe the physical world, and these models encompass a wide range of phenomena. So it's the study of motion, forces, heat, energy, sound, electricity and magnetism, light, optics, materials, atoms, nuclei, particles, space-time, stars, the cosmos, and pretty much everything else as well. So we are looking at these different aspects of the universe and asking ourselves why. Why do these aspects of the universe behave in the way that they do? And we try to create models. Often these models take the form of a mathematical equation or principle. And these models allow us to make predictions about, given a certain circumstance, how the universe will behave. So that is our goal. And since physics involves models that often are mathematical in nature, it's important to have hold of some good mathematical tools. So one of these mathematical tools is scientific notation. If we're studying everything from the smallest things in the universe to the very largest things in the universe, we need to be able to express a very wide range of numbers, really, really small numbers and really, really big numbers as well. And scientific notation allows us to do that in an efficient and compact form. So there's a couple of different ways in which scientific notation expresses numbers. If you have a large number, you can see that in scientific notation, you have a number out front times a power of 10 raised to some exponent. And the exponent tells you how you should move the decimal point to express the number in non-scientific notation. So for example, if you have this large number, if the exponent is 2, that means the decimal point needs to move 2 places to the right if you were to write this number without scientific notation. On the other hand, if you have a negative exponent, that denotes a small number and means that the decimal point needs to move 2 spaces to the left. Now below here on this slide you can see some rules for multiplying and dividing scientific notation numbers. So if you have a couple of scientific notation numbers and you're multiplying them, what you would do is multiply the numbers out front and then add the exponents to get the exponent of the resultant. So you can see that this is our result from doing that. And it's standard to only have one number to the left of the decimal point. So we would need to move the decimal point one additional place and express the final answer in this form. On the other hand, if you're dividing two scientific notation numbers, you would divide the two numbers out front and then subtract the exponent in the denominator from the exponent in the numerator. Now these examples show you how you would multiply and divide scientific notation numbers by hand. If you have a calculator, you can enter the numbers in as scientific notation numbers and then just use your multiplication and division buttons as normal. And if you do not know how to enter scientific notation numbers into your calculator, please see me and I can show you how. Now we'll also be using a lot of algebra and doing algebraic manipulations with equations. So this is just a reminder of some algebra facts. So with natural exponents and logarithms, you should remember from your algebra class that a natural exponent and a logarithm, these are the inverses of each other, and you use one to undo the other. So if, for example, we have an equation like 4 is equal to e to the x, and we need to get at x and figure out what x is, then to undo the e to the, where e is the natural number, we would take the natural logarithm of both sides of this equation. So the natural log then undoes the e to the and leaves us with just an x. And on the other side, when we take the natural log of 4 using our calculator, we get a numerical result of 1.39. If, on the other hand, we have a natural log equation, like the natural log of x is equal to 3, then we would undo this equation with e. Since e to the is the inverse of taking the natural log, e to the undoes natural log and we're left with x on the left-hand side. And then when we take e to the 3, if we put that into our calculator, we get an answer of about 20.1. All right, so let's try this. Here is an algebraic equation, and we want to find a value, a numerical value for x. So at this point, you should pause the video and try to figure this out. Try to get a numerical result for x, and then start the video up again and check your answer. Okay, so if you've been able to solve this equation and find a value for x, let's do this together and see what we get. So what value should we get for x? So first I'll rewrite the equation that we have above. E to the x minus 1 is equal to 1. Oh, and I need to divide that e to the x minus 1 by 2. So e to the x minus 1 divided by 2 is equal to 1. So the first step in solving this equation, I would need to get rid of this 2. So the first step would be to multiply both sides of the equation by 2. So the 2 on this side cancels with the 2 in the denominator, and so I would have e to the x minus 1 is equal to 2. Then the next step would be to add 1 to both sides, so I would have e to the x is equal to 3. And finally, to get at the x, I need to undo this e to the, so I would take the natural log of both sides. So the natural log of e to the x undoes the e to the, and so on this side I would just get x, which is equal to the natural log of e to the x. And then on the other side of the equation, I would have the natural log of 3. So the natural log of 3 is something I can put into my calculator, and if I do so, I would find that I would get a result close to 1.10. So that would be the answer that I would select. All right, another mathematical principle that we'll be using, particularly in lab, is linear equations. So these are equations where you have some value, some result, you have some input to the equation, y is your output, and when you plot the output versus the input on a graph, you get a straight line. Now the slope of this straight line is here, it multiplies the x value, and then the thing that gets added on at the end is the y-intercept, which is the point where the line crosses the y-axis. So just as a reminder, you can calculate the slope as being the rise over the run or the change in y over the change in x. So this means you need to pick 2 points on your graph and then find what the difference in the y direction is, as well as the difference in the x direction. Divide the two to find the slope. So as an example, let's find the slope of this line. So you should pause the video here and take a look at this graph with the line and see if you can calculate what the slope is. So now if you've calculated your answer for the slope, let's take a look at it. All right, so what's the slope of this line? So we remember that the slope is the change in y divided by the change in x. And so we need to pick two values where we're going to figure out what the change in y and the change in x are. So the couple really easy points to identify: the point where it crosses the y-axis, as well as the point where it crosses the x-axis. So if I use those as my 2 points, then the change in y will be this final point, and this final point has a y value of 0, minus the y value of my initial point, which is 3. And then the change in x, well, my final point is at x equals 4, and the initial point was at x equals 0. So what this is saying is that as I move from left to right, the line goes down in the y direction 3 units, and it goes across in the x direction 4 units. So my slope would be negative 3/4, and negative 3/4 is the same thing as negative 0.75. So I would select B as being my answer to this question. So that's it for video 2. In the next video, we'll continue to look at some math facts that are important and we'll be using throughout the course.